Hello, Algebra 2. It's Mr. Lambright. Yet again, I'm going to be wrapping up Chapter 1 with you guys today and tomorrow with two different lessons on 1.7, absolute value equations. So, let's take a look. So, an absolute value is basically saying, okay, we are going to take whatever number is inside the absolute value, and after we do the absolute value to it, it's going to be positive. If 2, we have the absolute value of 2, it is 2. The absolute value of -5 is 5. It strips the negative off, and if it's positive, it keeps things positive. Let's look at what this does when we have an equation like the absolute value of x minus 2 equals 0. See, here's the thing about 0. 0 is not positive, it's not negative, it's neutral. So it doesn't matter whether we had a positive 0 or a negative 0, it's just 0. So really, this is just the equation x minus 2 equals 0. We're going to add 2 to both sides. We get the solution x equals 2. On a number line, that is a big old solid dot right at 2. But something really different happens when we have a positive answer. You see, I can take the absolute value of 5 and get 5, but I can also take the absolute value of -5 and get 5. So I need to know when x minus 2 is in these brackets, I need to know what would make x minus 2 equal 5, and I need to know what would make x minus 2 equal -5. Let's check it out. I've got to do two different equations. X minus 2 equals 5. X minus 2 equals -5. I'm going to add 2. So x equals 7. Add 2. X equals -3. Because the absolute value would do the same thing to two different answers, to two different numbers, I actually have two different answers. X equals 7. And x equals -3 on a number line. -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7. That means I've got a solid dot here and a solid dot here. And those are my two different answers. Let's do another one. We can only split these into the positive and the negative versions when it's just the absolute value left on the left side of the equation, or if it were on the right, but for most of these examples, they're on the left. And so that's all that's on the left side of the equal sign. So we will split this into two equations. We're going to have x minus 5 equals 7, and x minus 5 equals -7, again, because whether it's 7 or -7 in the absolute value, x minus 5 has to equal one of those things for 7 to pop out. So we're going to add 5. X equals 12. We're going to add 5. X equals -2. So we've got -2. We've got 12. 0 is somewhere over here. And I've got solid dots on the -2 and the 12. That's a lot of hash marks for me to draw in, so I'm okay if we don't draw those in. All right, we're going to do the same thing on this problem. We're going to split it. 5x minus 10 equals 45. 5x minus 10 equals -45. And we are being told to check our answers. We're going to do that here in just a second. I'm going to add 10. 5x equals 55. Divide by 5, x equals 11. And again over here, we're going to add 10. 5x equals -35. And we'll divide by 5, x equals -7. So I've got two answers. I'm going to have to check them, though, to make sure that I don't have something weird going on. If you are catching up on the work, I would pause now because I'm about to erase it so I can check my answers. So we said x equals 11 and x equals negative 7. We're going to check them by plugging back in. So 5 times 11 minus 10 in absolute value brackets equals 45. We're going to have 55 minus 10 equals 45. 45 equals 45. And yes, the absolute value of 45 does equal 45. Then we're going to do the same thing with negative 7. So I got 5 times negative 7 minus 10 equals 45. Negative 35 minus 10 equals 45. Absolute value of negative 45 equals 45. And again, 45 does equal 45. See, the problem is sometimes we could have something called an extraneous solution. An extraneous solution is an apparent solution that must be rejected because it doesn't check out in the original equation. And you can imagine that there's probably going to be an extraneous solution in this next example. So what do we notice about this example? We notice we have variables on both sides. That's going on. And we also know that because we have variables on both sides, we've got a negative 4x and a positive 4x that we've got to check out. So we're going to split this up. 2x plus 12 equals 4x. And then also 2x plus 12 equals negative 4x. So we are going to subtract 2x. Twelve equals 2x. Divide by 2. And x equals 6. Same thing here, minus 2x. 12 equals negative 6x. Divide by negative 6. Negative 2 equals x. This would also be a good time to pause because we are going to check in this same space, which means I'm going to have to erase some of this work. So please pause if you need to get the work down. So we have our solutions. X equals 6, x equals negative 2. We need to plug them both back in where x was. So in the absolute value equation, I've got absolute value of 2 times 6 plus 12, close the absolute value, equals 4 times 6. 2 times 6 is 12. 12 plus 12 is, 4 times 6 is 24. 12 plus 12 is 24. It's still in the absolute value. The absolute value of 24 is 24. This checks out. X equals 6 is definitely a solution. And now we need to try x equals negative 2. We've got 2 times negative 2 plus 12, all in an absolute value, equals 4 times negative 2. 2 times negative 2 is negative 4 plus 12 equals 4 times negative 2, which is negative 8. Absolute value of negative 4 plus 12 is the absolute value of negative 8. And we think, oh yeah, we might have another answer that works. But the absolute value of negative 8 is positive 8. This does not work. This is not a solution. In fact, we should have known that back here at this step, because the absolute value of anything cannot be a negative number. So we know that this was a wrong answer. The only solution is x equals 6. We are splitting this into 2 lessons because the inequalities are a completely different animal when it comes to absolute value. But for now, you do have an assignment. Check it out on Canvas. If you have questions, email your math teacher or message us on Canvas, I should say. And we will see you tomorrow.